quartz, and other substances that have a lot of silicon dioxide in it. This material, silicon dioxide, has a very low specific gravity. It's extremely buoyant. It will have a tendency of floating on the asthenosphere without any problem. The continental crust is old, up to 4 billion years old. So the continental crust is extremely old. Oh, continental crust 4 billion plus. Now, if we look at the continental crust, this is our general elevation of the landscape. And we have an upright mountain peak. That mountain is being supported by material well below the surface. So this is where we get the maximum thickness of continental crust. As this mountain is wearing away, erosion is reducing it in scope. This blob of material will rise to the surface. So as this is being eliminated at the top, this is being pushed upwards. Remember, it's very, very lightweight stuff that is being pushed up. And when I say lightweight stuff, it's granite, basically. No, it's not puffy stuff, but it's lightweight compared to everything else. So as this is undergoing erosion, this is being pushed up. So after a period of time, what we might be looking at in the same area is something like this, where literally it has pushed up over a period of time. And that's why erosion never takes anything down to sea level. There's a rebound possibility here. And that's basically what we're looking at. That as stuff is taken off, the Earth rebounds, and it doesn't maintain its same elevation, but it tries to compensate for the loss taken out by erosion. Okay, so back to this, both of these, the continental crust and the oceanic crust, are referred to as the true lithosphere. And remember, we mentioned the lithosphere as being the top segment of planet Earth. So continental crust, oceanic crust are the true lithosphere. Okay, as we look at the planet and landscape features, planet Earth and landscape features. We can divide all features basically into two categories: continental base and ocean base. So all landscape features will fall into obviously one of these two categories. How much of the planet Earth's surface is ocean?
70%.
71%, right? So continental will be
29.
Obviously 29. So let's look at the continental segment first. Pardon me, the ocean basin segment first. Just turn this over. Okay, and this repeats over on this side. Now we're going to throw in the ocean. Sea level. When we look at the land features of the ocean basin, we fall into three categories. First category, A here, equals the continental margin. The continental margin is literally the extension of the continent that is below sea level. So it's included in the ocean basin. But geologically speaking, it is part of the continent. So it can be relatively old material. B, we have location B, is the ocean basin floor. The ocean basin floor, as the name implies, represents the deepest segment of the ocean. And C, one book calls C the ocean ridge, the other book calls it the mid-oceanic ridge. But in all practicality, it's not in the center of the ocean, it's off to one side. Okay, these are the major components of the oceans. But we're going to break them up into subunits. What's that part of the ocean basin floor that extends out from the continent, maximum depth about 600 feet? This is where they drill oil. This is where the oil platform blew a gasket a year or so ago. Okay, this is the continental shelf. Okay, so the continental shelf is a relatively flat surface, gradually sloping toward the ocean basin floor. Typically, the thickness here, or the depth of the landmass, about 600 feet, plus or minus maybe 50, depending on location. It's covered with sediment debris, dead animals, dead people, dead leaves, whatever happened to wash into its place. So this has a thin veneer of sediment on it. The Titanic is not on that, it's in slightly deeper water. Then we have almost a vertical cliff face. It's not quite vertical, but it's relatively close, called the continental slope. And it literally marks the edge of the continents. It looks like this is ripped away from something. It's that vertical. Then at the bottom, you see where it kind of tapers off? That's continental rise. And this is basically an accumulation of Jimmy Hoffa's bones and so on, been dumped into the water, accumulating at the base of this. So sediments that wash out a little further will wash out and drop at the base of this. So it's kind of a deposit. It's not solid rock, it's a deposit of materials that have washed off the land surface over time. Okay, frequently, not always, but frequently adjacent to the continent, we find the deepest segment of the ocean basin floor, and they are the trenches. Trenches are deep enough that you could throw Mount Everest into a trench and still have almost a mile of water above Mount Everest. These things are deep, they're small, they're narrow, but they are deep, and there are some rather interesting life forms at the edge of the trenches. The trenches are part of the ocean basin floor. Trench is part of the ocean basin floor. The largest landmass on on planet or one of these flat